This is pre-calculus section 5.3 on solving trig equations. Notice our directions here to say solve between 0 and 2 pi. Brackets on one side, parentheses on the other. That means a couple of things to us. First of all, our answer needs to be in radians. Secondly, if there's a choice between having an answer of 0 or 2 pi, they're the same angle, but we would use the answer of 0 because we're looking at the bracket there, rather than the answer of 2 pi. And there might be more than one answer. In fact, there's usually more than one answer in this kind of problem because we have to think about different quadrants where our answer can take place. Let's go ahead and jump into an example. 2 cosine of x minus root 3 equals 0. So first off, we're going to add root 3 to both sides. Then divide both sides by 2. And we have this. A couple things to consider. First of all, cosine is positive. And cosine is positive in the first quadrant as well as in the fourth quadrant. So we're looking for answers that are in those two quadrants. And thinking about the first quadrant, where is cosine equal to root 3 over 2? The cosine is dependent on x. It's pretty far to the right. So I know that this is 30 degrees. Or in terms of radian, that would be pi over 6. And then in the fourth quadrant, we want that same reference angle all the way around like that. So it doesn't quite make it all the way to 2 pi. It's, in fact, pi over 6 less than 2 pi. So 2 pi minus that gives us our second and final answer of 11 pi over 6. Second one, subtract 1 from both sides, divide by 2. We get sine of x equals negative 1/2. Same general idea. We want to, first of all, decide where does this occur. Where is sine negative? That would be in the third quadrant and the fourth quadrant. Where is sine equal to 1/2? Just a positive 1/2, ignoring the negative part. That would be at 30 degrees or pi over 6 radians. So to find our two answers in the correct quadrant, have a sine equal to negative 1/2. In the third quadrant, we'd have pi plus another pi over 6. And then our other answer is going to be in the fourth quadrant with that same reference angle. Now it doesn't quite make it all the way to 2 pi. In fact, it's pi over 6 less than 2 pi. And that gives us another answer of 11 pi over 6. Alright, the next one, we have two trig functions multiplied by each other. And I don't want to work with two different trig functions at the same time. So we will get everything in terms of sine and cosine. And thankfully in this case, those signs eliminate each other. We have one in the numerator, one in the denominator. So it becomes 2 times the cosine of x is equal to the square root of 2. Divide both sides by 2. And now solve this one. So thinking about quadrants again, cosine is positive in the first quadrant and the fourth quadrant. Where is cosine equal to root 2? Well, at 45 degrees or pi over 4 radians. So one of our answers is pi over 4. The other answer is in the fourth quadrant with that reference angle. So it's pi over 4 less than 2 pi. In other words, take 2 pi minus the pi over 4, and we get 7 pi over 4. Okay, here's our next example, and once again we have two different trig functions. So we'll get everything in terms of sine and cosine again. And we have a fraction as well at this point. There's a cosine down in the denominator. Thankfully the right side is equal to 0. So to solve the problem with this trig function down in the denominator, we're going to take cosine of x and multiply it to all three of those terms, the two terms on the left as well as the one term on the right. So now we're going to have 2 cosine squared of x multiplied by the second term. That's minus 1. That looks a little bit simpler. And when you take cosine of x times 0, it stays 0 over there. So what we've accomplished is we have no more denominators. Let's go ahead and add 1 to both sides. Divide by 2, and we get cosine squared of x equals 1/2. But we don't want cosine squared, we want cosine of x. So take the square root of the left, take the square root of the right, and because we're solving an equation and taking the square root, we have to include the plus or minus. Going a little bit further with this, cosine of x equals plus or minus the square root of 1 over square root of 2. Simplifying down more, the square root of 1 is 1, the square root of 2 we don't know, and we don't want a square root in the denominator, so we're going to rationalize it by multiplying by root 2 over root 2, which ultimately gives us that cosine of x is either the positive or the negative square root of 2 over 2. Now we want to solve that. We took the original equation, did some algebra on it, simplified to this. Now we want to know what angles have a cosine that are equal to either positive root 2 over 2 or negative root 2 over 2. So unlike the other ones, we have all four quadrants in play for this one. The reference angle is going to be pi over 4. That's where cosine is equal to root 2 over 2. So in the first quadrant, we have an answer of pi over 4. In the second quadrant, we have 3 pi over 4. In the third quadrant, we have 5 pi over 4. And in the fourth quadrant, we have 7 pi over 4. Okay, so here's the next example. And everything is already in terms of sine and cosine. However, I don't want both sine and cosine. I'd rather have just one trig function. So we're going to make a substitution in this problem right away. In fact, cosine squared is equal to 1 minus sine squared. That's one of our Pythagorean identities, or at least it's a variation of that. So now when we combine like terms, we would get 4 sine squared of x minus 1 equal to 0. That negative sign distributes. Now we are going to add 1 and divide by 4. So sine squared of x equals 1/4. Take the square root of both sides, and we get plus or minus the square root of 1/4. Simplifying that a little bit, sine of x equals plus or minus the square root of 1 over the square root of 4, so that's 1/2. So we're looking anywhere that sine is either a positive or a negative 1/2. Reference angle for this one is going to be pi over 6, which is 30 degrees. So we're going into all four quadrants, pi over 6. Second quadrant is 5 pi over 6. Third quadrant is 7 pi over 6. And then in the fourth quadrant we get 11 pi over 6. So these four answers all work for that original equation. For the next example, we're going to look at just a regular polynomial function. Solving this equation, which is equal to 0. I know it's a trinomial, it's a quadratic, so I can factor it as 2x plus 1 times x minus 1 equals 0. And then I'll show a little bit more work than normal. I'll take each one of these parts, each one of these factored parts, set them equal to 0. So the first factored part gives us an answer of negative 1/2. The second one gives us an answer of x equals 1. So this is just a step back to do a polynomial equation, and we're going to relate that to this next one over here to the right. As I look at this equation, I see that there's a sine squared, a cosine squared, and a cosine. I don't want to have multiple trig functions, so we're going to do a conversion. And since this cosine of x is just to the first power, what I'm going to do then is rewrite this sine squared, make the substitution, and call that 1 minus cosine squared. Next step, let's make the left side equal to 0, so add cosine squared to both sides, which now gives us 2 cosine squared on the right. Still a negative cosine of x, and then we're going to subtract 1 from both sides to get that equation. And what's significant about this equation is that it's essentially the same as that polynomial equation that we just looked at. And that's going to give me a little bit of an idea of how to factor this one. Instead of 2x plus 1 times x minus 1, it's going to be 2 cosine of x plus 1 times the cosine of x minus 1. Factored just like the other one, but has cosine in it now. And if we take this first part, set it equal to 0, we get cosine of x equals negative 1/2. And if we set the second one equal to 0 and solve that, we get cosine of x equals 1. We're looking for the solutions then. Where does cosine of x equals negative 1/2? Well, that'd be in the second and third quadrant where we have a negative cosine. In the first quadrant, pi over 3 is our reference angle. So if we go into that second quadrant, we're going to have an answer of 2 pi over 3. If we go into the third quadrant, we're going to have an answer of 4 pi over 3. And then our other factored part is where cosine of x equals 1. So to draw that one out, cosine equals 1 right there. That's at 0 and also at 2 pi. However, our directions told us that we want all the answers between bracket 0 and 2 pi parentheses. In other words, 2 pi is not going to be included. So those are the three answers that we're going to write. Here's our last example on 5.3 section 1. First of all, we'll get everything in terms of sine and cosine. Just making a substitution in for tangent. And then because we have that denominator of cosine, I'm going to multiply everything, all three of these terms, times cosine. It gives us cosine squared of x plus sine squared of x equals 2 times the cosine of x. Again, the reason to do that is because we have this cosine of x in the denominator. When we multiply cosine times cosine, that's cosine squared. Cosine times this quantity. We did it to get that cosine in the denominator to cancel out. We're left with only the sine squared. And then cosine times 2 gives us that product we have on the right. The nice thing about this problem is that on the left-hand side, that is a Pythagorean identity. Sine squared plus cosine squared equals 1. Divide both sides by 2. So now we're looking at where does cosine of x equal 1/2. In the first quadrant and the fourth quadrant, we have our positive cosines. In the first quadrant, then the answer is going to be pi over 3. And in the second quadrant, then the answer is going to be 5 pi over 3.